Titrations. Well, first things first, what is a standard solution? A standard solution, well, it involves dissolving a known amount of solid and a known amount of water to create a known concentration. It's just a solution, you know the exact concentration of, that's all it is. Equal to volumetric solutions. Making a standard solution. Place a weighing boat on a digital balance and weigh out this mass of solid. Tip it into a beaker and reweigh the boat. It still contains traces of solid. Subtract the mass of the boat from the mass of the boat and solid together to find the precise mass of solid used. Add distilled water to the beaker and stir until it has all dissolved. Tip solution in a volumetric flask and use a funnel to ensure it all goes in. Rinse the beaker and stirring rod with distilled water and add to the flask. This ensures there's no solute clinging to the beaker/rod. Top the flask up to the correct volume with more distilled water and make sure the bottom of the meniscus reaches line. Stop at the flask, turn it upside down a couple of times to ensure it is mixed. Using a pipette to measure out a set volume of solution you want to know the concentration of. Well, the thing about pipette is they only measure only one volume of solution. Therefore, we need to fill the pipette to just above the line and then take the pipette out of the solution and drop level down carefully down to the line. Add a few drops to the flask, fill a burette with standard solution of the acid, use funnel to carefully pour acid in the burette, now ready to titrate. Doing a rough titration. Now, rough titration is to get an idea of the end point. The exact point where alkali is neutralized, exact point where acid is neutralized and alkali change in color. Now we need to add acid to alkali using a burette, giving the flask a regular swirl. Do an accurate titration, take initial reading, see how much acid is in it in the burette. Run the acid within 2 cm³ endpoint and add dropwise. Then the titer, which is the amount of acid used to neutralize the alkali. Indicators that change color quickly over very small pH range are used so you know exactly when the reaction ended. Methyl orange, red in acid, yellow in alkali, phenolphthalein colorless in acid, and pink in alkali.